Bluetooth mode. Set light is now connected. Light is now disconnected.
So, is there any disturbance of the fan? Okay, shall we start that? Completed? Taking down the problem?
So your voice is not clear.
Voice is not clear. Is that issue with everyone or only with you?
No, sir, voice is not clear.
Is that okay now?
Yes.
Okay. Shall we start the problem then?
No, sir. The 2 minutes, sir.
Okay. So in between the class, I may ask any one of you to switch on your camera and show how much you have worked on your paper. So I want every one of you to solve this problem in the same pace with which I am solving here. Okay, so I would ask any one of you in between to just switch on your camera and show us how much and what you have solved. So make sure you solve the problem within the class itself. Okay. Shall we start? So he says there is a gas engine working on a constant volume cycle. So constant volume cycle in the sense it is Otto cycle for results of 1 hour test. So the test duration is 1 hour. Can they write it down? Okay. Just give me the given data because we cannot keep on scrolling up and down. Okay, given data. So he says it is a constant volume cycle. Okay, and test duration is how much? It is 1 hour. Next, what does he say? Any other parameters given? Just check whether the engine parameters are given anywhere. Okay. Diameter of the engine is given, or diameter of the cylinder is given. It is 24 centimeters. 24 centimeters in the sense it is 0.24 meters. Am I correct? Similarly, stroke is 0.48 meters. Effective diameter of the brake wheel. Now, the brake wheel parameters is mentioning. So, I will be drawing a small figure like this to indicate. So diameter, effective diameter, he says. So you can say effective dia. So that T is nothing but capital D. How much he has given? 1.25 meters. Next, net load on the brake drum. So W minus S. This is the net load. So remember, when you say it is effective dia, then you can directly take it as capital D plus small d divided by 2. Okay. When he says net load, it is W minus S directly given. How much is that? 1236 Newton. That's great. Average speed he has given, so N. I would be writing near the crankshaft here. N is equals to how much? 226.7 RPM. Okay. This is different. Yes.
That net load 12.36 net load 12.36 or 1236.
1236.
Okay, okay, okay.
1236. Okay. That's 1236. Now, so since this is a gas engine, so this particular sentence is being given. What is that sentence? Gas used is 13 meter cube. 13 meter cube at 15 degrees Celsius and 771 mm of mercury pressure. So this particular sentence he has mentioned. Okay. And calorific value of the gas he has given, CV value of the gas, and that is how much? 22,000 kg per kilojoules per meter cube. It's kilojoules per meter cube. Make sure about this units. It's meter cube, not kg there. Okay. Next is cooling water parameters he has given. I will just write cooling water. Okay. So since cooling water parameters are given, he might ask us to draw heat balance sheet. Let us see. Cooling water, mass of the cooling water used is 625 kg. Next is rise in temperature. So delta T of cooling water. Rise in temperature. How much he has given? He has given it as 35 degrees centigrade. So this is the rise in temperature. NTP conditions are 760 mm of Hg and 0 degrees Celsius. That is NTP conditions. No issue. So now, what all we require to find? To find, first one, we need to find the mechanical efficiency. Number 2 is specific fuel consumption. So even he has mentioned as the units, in which units he is required. So it is meter cube per IP hour, he says. So the units required for this is meter cube per IP hour. Let us see when it comes actually. Next, third one he has asked is indicated thermal, brake thermal efficiencies. And at fourth, and at the last, he has asked us to draw a heat balance sheet. So this is the story of the problem given. Okay. Any doubts until now? Any doubts? Any doubts, guys?
No, sir.
Shall we go on with the solution now then? Ashir, not clear. Okay, you're talking about the audio. Okay, now we shall move with the solution. Try to calculate BP, try to calculate IP, try to calculate mechanical efficiency. Everyone, let us see with the available data. So I already said you that we are sending the reports on the weekly basis to the VTU. That report will be mentioning how many students attended and how many students did not attended the class in that particular week. Okay, so if you come at the nth moment after 3 to 4 months during the end of the semester, we will be not in a position to change your attendance. So keep this point in your mind and please do attend all the classes regularly. Okay. Even at the end of this class, we will try to share the attendance sheet of yours and you can check your attendance status till now. Okay. Okay. Solution. So first one, what he has asked? Mechanical efficiency. Okay, we'll just take another page. We'll draw the solution here. Okay. So now, so first thing he has asked us is the mechanical efficiency. For mechanical efficiency, you know that it is BP divided by IP cross 100. So first now calculate BP. BP is nothing but it is 2 pi NT by 60. N you know, but T you don't know. So T is equals to W minus S into capital D plus small d divided by 2. So W minus D net load cumulatively he has given it as 1236 cross capital D plus small d divided by 2. Effective diameter he has given it as 1.28. So whatever torque you would get, that is would be in Newton meters. So what is the value? What is the value, guys?
1582.08.
1582.08. 1582.08. So once you got the torque, use the BP expression over there. So BP is 2 pi N. He has given it as how much? 226, I guess, something 226.7. Okay, cross the value of torque is 1582.08. So this whole divided by 60. So what is the value of BP that you have got? Yes, Mohan Chandra. Sujan.
sir.
37.5 into 10 to the power 3.
27 point
37.5.
37.5. Okay. 37.5 into 10 to the power 3 have said, so it is kilowatts, right? Next, go for IP. So just mark it with a box. It would be easy to pick up later. So next, go for IP. So what is the configuration given? Whether he has mentioned 2-stroke, 4-stroke, what it is. Any information given regarding 2-stroke or 4-stroke? So usually gas engines would be of a 2-stroke engines. There will never be a 4-stroke engine for a gas engine. So you can take for plan divided by 60. So why you have taken this, you can just mention in beside, because it is a gas engine. So we are assuming it to be a 2-stroke and single cylinder. Okay, so that is why we have taken that. So just try to, do I have the value of PM? Do I have the value of PM? PM is not given. He has given. You have not taken it, that's it. Okay, PM value he has given it as 7.5 bar there. So just write it. So PM he has mentioned it as 7.5 into 10 to the power of 5 Newton per meter square. The same thing I will take here to solve it. Okay. So IP value is equal to 7.5 into 10 to the power of 5 cross. L value was 0.48 and area is nothing but pi by 4 d square, and d square value was 0.24, its whole square, cross n value was something 226.7. So this whole divided by 60. Now, what is the value of IP that you have got? Again, give me it in kilowatts. That would be better. So once you have got IP, mechanical is nothing but BP divided by IP cross 100. So BP it is 37.5. Just substitute the values and even calculate the mechanical efficiency.
$61.5.
61.5
into 10 to the power 3.
kilowatts. So BP is 37.5 and IP is 61.5. So it could come around just about 50. What is the value of mechanical efficiency then?
$60.94.
60.94%. So So that completes your first bit. Was the second bit asked? Specific fuel consumption. Okay. Second bit he has asked is specific fuel consumption. Even he has given the units in which he has gone, so it is meter cube per IP hour. So he wanted in meter cube divided by IP hour. So since there is an IP in the units, you can just assume it as indicated specific fuel consumption. So that is given by mass flow rate of the fuel divided by IP. Okay, mass flow rate of the fuel should be in meter cube per hour. Okay, you can just write it here. So mass flow rate of the fuel, just by analyzing the units, it should be in meter cube per hour. So how do I calculate the mass flow rate of the fuel? Any idea, guys? Is there any parameter given to calculate the mass flow rate of the fuel? So first of all, which type of fuel is this particular engine is using? What is this jam board? Any idea?
Sir, something I unknowingly did, sir. I don't know.
Achha. Even I'm trying that. It seems interesting. Let's see after that. Okay, we don't have time now. Yes. Which type of engine is that? I mean, which type of fuel is your engine using? Hey, petrol use ಮಾಡ್ತಾ ಇದ್ದಾನಾ, diesel use ಮಾಡ್ತಾ ಇದ್ದಾನಾ, ಏನು use ಮಾಡ್ತಾ ಇದೆ?
Gas.
It's using a gas, isn't it?
Yes, sir.
Okay. So the only parameter which he has mentioned is this particular thing, isn't it? Are you able to see the screen?
Yes, sir.
No, sir.
Okay. Enough?
It's visible, sir.
Okay, fine. So let us take this line. Gas used is 13 meter cube at 15 degrees Celsius and 7771 mm of mercury pressure. So let us take that line and try to extract our parameter. Okay. So he says 13 meter cube of gas is being used at 15 degrees Celsius and at 771 mm of Hg. So that is the statement which is given. Now, 771 mm of Hg is nothing but the pressure parameter. So this is the form of pressure. So bar is a unit of pressure, isn't it? Even similarly, Newton per meter square, megapascal, all those are units of pressure. Even the column, water column, mercury column is also a unit of pressure, where 771 mm of Hg can be converted into a pressure form using an expression. You have to remember this, which is P is equals to rho g h. Okay. So using this particular expression, you can convert the mm of Hg to Newton per meter square. Now, what is the density of mercury? It is 13,600. You have to even remember this. I'll be marking it in red. So 13,600 is the unit of, the value of density of the mercury. Cross, it would be in kg, and g is in 9.81 is the value of g, and h is 771 mm. So substitute in meters. Okay, it is 771 cross 10 to the power of -3. So if you do all those stuff, whatever you get, you would get in Newton per meter square. So what is the value of pressure at which the gas is being sent? What is the value?
102,863.7.
Okay, give me 10 some considerable number, 1.2 or something like that, into 10 to the power of something.
1.02 into 10 to the power 6.
1.02 into 10 to the power of
6, sir.
6, huh?
Yes.
Okay.
102.86 minus 3.
-3, yeah. Is the value correct which I have written?
Yes.
Raised to
Sure.
3, right? 1.2.
Sir,
10 raised to 5, sir.
10 raised to 5, ah. Okay. So this is 10 raised to 5.
10 raised to 5, sir. Ah.
Now it is correct. Correct and wrong.
Yes, yes.
Yes, sir.
It's given the temperature, isn't it? So temperature is 15 degrees Celsius. So convert into Kelvin, plus 273. So the value in Kelvin is 15 plus 273 is 288, I guess, right?
yes, sir.
288 Kelvin. Now, volume is also given. So volume is how much? 13 meter cube of volume. So why all these parameters is given is, you have to use here PV is equals to M into R into T. Now, from this, M is equals to what? It is RT divided by PV, right? And what is the value of R, guys?
Constant.
8.64.
9.3.
Value of R I would give you, just try to remember it as 0.287 into 10 to the power of 3. Okay, so this is the R value. Now, what you do is just substitute everything. Okay, just substitute everything and calculate the value of mass of the gas which is being sent. Okay, it is not RT divided by PV,
Sir,
it
is R
is PV
constant?
divided by RT. It is PV.
Sir, R constant.
How the R constant? Gas constant, Allah. So M is equal to, it is PV divided by RT. So m is equal to p n anta helidri 1.02 into 10 to the power of 5 anta helidri. V is nothing but 13 meter cube divided by R is 0.287 into 10 to the power of 3 cross temperature 288. So whatever you get, that would be in kg. So what is the value?
16.04.
So 16.04 kgs of gas is being used in how many hours?
1 hour.
1 hour. So the sentence which was given was 13 meter cube of gas at 15 degrees Celsius and 77 mm of mercury. From this, you have extracted the value to be 16.04 kgs. Okay, so this is an important step. Whichever is required to be remembered, I have marked in red color. Even you can mark it in your notes with the help of a pencil there. Okay. Very good. Now, if I go for the mass flow rate of the gas or mass flow rate of the fuel, it is how much? 16.04 kg. So the test duration is how much? The test duration is 1 hour. So it is kgs per hour. Okay. Now, but when you come here, okay. Now, keep this aside, just mark a box onto it like this. Okay. Now, come back to this. We were in search of SFC, isn't it? So, SFC is equals to mass flow rate of the fuel divided by IP. Okay. So, what is the unit that he wants? He wants it in meter cube divided by IP hour. Correct? Is this the statement?
Yes.
Now, you have the value of IP, isn't it? It is 61.5 kilowatts. Now, in what units, all of you listen this question carefully. In what units I need to substitute the value of EMF so that I would arrive with this particular units at the end? Whether I should substitute the value of MF in kgs per hour, or I should substitute the value of EMF in meter cube per hour to arrive at the unit which he has asked for. So in which units I should substitute it? Yes, guys.
Meter cube per hour.
kg per hour.
Meter cube per hour, isn't it? Now, if I want the units of mass flow rate of the fuel in meter cube per hour, it is simply, okay, how many meter cube was going? 13 meter cube of gas was going. So it is 13 meter cube per hour. So test duration is 1 hour. It is just 13 meter cube per hour because test duration is just 1 hour. Correct? So this is mass flow rate of the fuel in terms of unit meter cube per hour. Now you go for the specific fuel consumption formula. Mass flow rate of the fuel is 13 divided by IP value was 61.5, and whatever answer you get, that would be in meter cube per IP hour. What is the value? Hey, just a division, man. How much time you are taking?
0.211.
0.211.
211.
Okay. So I would just finalize this particular value. Just check whether it is correct or not. It would be correct, man. No issue. Done. So second unit is done. Okay. Next is third subbet. Third, what he has asked? He has asked indicated thermal efficiency and brake thermal efficiency. So how do you calculate indicated thermal efficiency? Yes. How do you calculate? What is the formula?
IP divided by m dot f into c.
IP divided by m dot f into CV. Okay. Now, what are the values? Just write it behind that. So IP is equal to how much? 61.5 kilowatts. And MF dot you have, you can substitute either in meter cube per hour or kg per hour. We shall see. Okay, now what is the value of CV? 22,000. CV value was 22,000 kilojoules per meter cube. Okay, so this is the thing. Now, before I substitute, I want to decide whether I have to substitute in meter cube per hour or should I substitute in kgs per hour. Okay, so that is the confusion we are having, isn't it? So for that, you have to match the units. So how do you match the units? Now, IP would be in what? IP would be in kilowatts. I want the below term, the denominator term also to be in kilowatts. Yes or no? So for that reason, what is the denominator? Denominator is MF dot into CV. Now, the CV value which is given as in which units? Kilojoules per meter cube. Okay, now, according to you, in which units should I substitute here? To get the value, the ultimate result should be in kilowatts. So in which units should I substitute the value of MF dot so that ultimately I get kilowatts at the end? Think and say me.
kg.
Praveen. Kishan Kotian.
Yes, sir. Yes, sir.
So ಯಾವ ಯೂನಿಟ್ ಅಲ್ಲಿ ನಾನು MF ಡಾಟ್ ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು so that ನನಗೆ ಎಂಡ್ ರಿಸಲ್ಟ್ ಕಿಲೋವ್ಯಾಟ್ಸ್ ಅಲ್ಲಿ ಬರ್ತದೆ.
Meter cube by hour.
Yes.
Meter cube by hour.
Okay, ಮೀಟರ್ ಕ್ಯೂಬ್ ಪರ್ ಅವರ್ ನಾನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಇವಾಗ ಏನಾಗುತ್ತೆ, ಮೀಟರ್ ಕ್ಯೂಬ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಎಂಡಿಗೆ ಉಳಿಯೋದು ನನಗೇನು ಕಿಲೋ ಜೌಲ್ಸ್ ಪರ್ ಅವರ್, ಬಟ್ ಜೌಲ್ಸ್ ಪರ್ ಸೆಕೆಂಡ್ ಇಸ್ ವ್ಯಾಟ್. ಕರೆಕ್ಟಾ? ಜೌಲ್ಸ್ ಪರ್ ಅವರ್ ಯಾವ ಯೂನಿಟ್ ಅಲ್ಲ. ಸೊ ವಾಟ್ ಶುಡ್ ಐ ಡೂ ಆದಿತ್ಯ?
Meter cube by second.
ಓಕೆ ಫೈನ್. ಈಗ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ ಅಂತಂದ್ರೆ, I would substitute the values in meter cube per second. Now let us check. So meter cube goes away. The remaining units is kilojoules per second. So joules per second is watt. So kilowatt you would get at the denominator. Correct? So I want the value of MF to be substituted in meter cube per second. Got it? ಹೇಗೆ ಅನಲೈಸ್ ಮಾಡೋದು ಅಂತ ಗೊತ್ತಾಯ್ತೇನ್ರೋ ಎಲ್ರಿಗೂ?
Yes, sir.
Yes, sir.
I want response from everyone.
Yes, sir.
Okay. So now what you have to do is you have to get the value of MF dot in meter cube per second. I have the value of MF. I have the value of MF in what? I have the value of MF in what? So how do I convert meter cube per hour to meter cube per second? So for that I should divide it by 3600. Now the value would be in meter cube per second. Now we can substitute the value and calculate your indicated thermal efficiency. Substitute ಮಾಡಿ calculate ಮಾಡ್ರೋ. ಎಷ್ಟು ಬಂತು ನೋಡುವ. So indicated thermal efficiency is equal to IP value was 61.5 in kilowatts. Below value was 13 divided by 3600 in meter cube per second. C value was 22,000. So all this into 100. So indicated thermal efficiency, whatever you get, you would get in percentage now. So after this, calculate the break thermal efficiency. So break thermal efficiency is similar thing. It is BP divided by MF dot into CV. So substitute the value of BP. BP is to calculate ಮಾಡಿದ್ರಲ್ಲ 37.5. 37.5. Same thing. MF dot is how much? MF dot is 13 divided by 3600 cross CV is 22,000 cross 100. Now break thermal efficiency is equals to, again you get it in percentage. So give me both the values. Now okay,
77.41%.
77 huh?
Yes, sir.
77.41. Next.
0.48. 47.48.
47.2%. Very good. Okay. So third subbit is done. Last one is which one? The fourth one is the heat balance sheet. Okay. For the heat balance sheet, any criteria he has given? Just check. So he has asked us, look here. So first, whenever there is a question on heat balance sheet, you have to check whether you have to do it in minute basis or hour basis. So accordingly, you have to choose it. Okay. I would take the heat balance sheet of the previous problem. So now you have to do it in minute basis, not in hour basis. So I would just change it to minute. Okay. All other things will remain same. Okay. So how do you calculate the value of QS? Yes, all of you draw the heat balance sheet. For a moment, just take a screenshot of this. Okay. Now, Nikhil, can you just present yourself? Switch on your camera.
Yes, sir.
Very good. Do it. I would just stop presenting from here. Nikhil, show us your notes.
Sir.
Problem ತೋರ್ಸೋ ನಿಖಿಲ್.
ಸರ್ ಮಾಡ್ತಿದ್ದೆ ಕಾಣ್ತಿಲ್ಲ ಸರ್.
Good. Go on. Yes, Raj Prasad, stop presenting, Nikhil. Switch off your camera. Raj Prasad. Nikhil, ನಿನ್ನ ಕ್ಯಾಮೆರಾ ಟರ್ನ್ ಆಫ್ ಮಾಡು ಸಾಕು.
ಓಕೆ ಸರ್ ಸ್ವಲ್ಪ ಸ್ಟಕ್ ಆಗಿದೆ.
ಹೌದಾ, ತೊಂದರೆ ಇಲ್ಲ, ಮಾಡಿ. ಮೀಟಿಂಗ್ ಇಂದ ಎಕ್ಸಿಟ್ ಆಗಿ ಮತ್ತೆ ಪುನಃ ರೀಜಾಯಿನ್ ಆಗು, ತೊಂದರೆ ಇಲ್ಲ.
ಓಕೆ ಸರ್.
ಎಂತದು ಆಯ್ತು, ಕುಟ್ಬೇಡು, ನಿಧಾನ ಮಾಡು, ಹಾಳಾಗುತ್ತೆ ಮೊಬೈಲ್. So all of you just try to solve the heat balance sheet. I will be checking everyone's heat balance sheet. Same procedure, nothing changed there. Okay. Enter the values over there. QS you can find it out. Okay. Calculate the value of QBP, calculate the value of QCWF and QUA. We will check one by one now. Okay. Now, yes, Raj Prasad, can you switch on your camera? Raj Prasad. Okay. No need to mark the attendance till I say, everyone. Okay. So when I say, then only you can mark your attendance. I have removed everyone. Raj Prasad. Responsible. Next. Sohan Devadiga. Sohan.
Yes, sir.
Can you please switch on your camera, Sohan, and show us your problem. Make it fast. Make it fast.
ಸರ್ ನಾನು ಈಗ ಜಾಯ್ನ್ ಆದ ಸರ್ 2:30
Huh? ಏನೋ
2:30 ಜಾಯ್ನ್ ಆದ ಸರ್ ನಾನು
ಲೇಟ್ ಆಗಿ ಜಾಯಿನ್ ಆದದ್ದಾ? ಸರಿ, ನೀನ್ ನಿನ್ನೆ ಮಾಡಿದ ಪ್ರಾಬ್ಲಮ್ ತೋರ್ಸು, ಮೊನ್ನೆ ಮಾಡಿದ ಪ್ರಾಬ್ಲಮ್ ತೋರ್ಸು. This is the fourth. Which problem is that? How many problems you have solved, by the way?
Third. Three.
Third problem. Third or fourth problem. ನಿನ್ನೆ ಮೊನ್ನೆ ಮಾಡಿದ ಪ್ರಾಬ್ಲಮ್ಸ್ ತೋರ್ಸು ನನಗೆ. Show your notes. That's it. Sohan, last chance, man. Next up, Wayne. Barboza, Wayne. Sohan ಏನು ಅಪ್ಡೇಟ್ ಇಲ್ಲ, ಆಕ್ಟಿವ್ ಇಲ್ಲ ಕ್ಲಾಸ್ ಅಲ್ಲಿ. Sohan. Wayne Barboza. Are you there? Wayne? Not there. Next. Syed Anwar. Syed Anwar.
Yes, sir.
Switch on your camera, Anwar. Are you in your hometown? Reached already?
Yes, sir. I am in my home.
Very good, very good. Show us your problem.
Yes, sir.
Fast, Anwar, we don't have time.
Yes, sir.
Switch on your camera. Marvin Pinto. Marvin.
Yes, sir.
Camera on ಮಾಡು. Syed Anwar hasn't responded. ಆಯ್ತಾ ಮೆರ್ವೆನ್? ಎಷ್ಟೊತ್ತು ಬೇಕು? Okay, Mervin. Good. Next, Swijan Rai. Swijan.
Sir.
ತೋರ್ಸು, ಎಷ್ಟು ಮಾಡಿದೆ ಹೀಟ್ ಬ್ಯಾಲೆನ್ಸ್ ಶೀಟ್? Switch on your camera, Swijan. ಬಂತ ವ್ಯಾಲ್ಯೂ? QS QB
ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಸರ್.
ಇದೆಯಾ? ಮಾಡು,
ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಸರ್.
ಮಾಡು. ವೆರಿ ಗುಡ್. ನೆಕ್ಸ್ಟ್, Omar Zidane. ಇಲ್ಲ ಕ್ಲಾಸಲ್ಲೇ ಇಲ್ಲ. ಡು ನಾಟ್ ಮಾರ್ಕ್ ದ ಅಟೆಂಡೆನ್ಸ್. ನಾನು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನರೇಂದ್ರ, ವೆಯ್ಟ್ ಮಾಡು. ಇವನು ಸುಜನ್ ಎಲ್ 19 MB 36 ಇದೆಯೇನೋ?
ಎಸ್ ಸರ್.
ಕ್ಯಾಮ್ರಾ ಆನ್ ಮಾಡು. Okay. Now all of you just mark your attendance in the Google sheet. Last few minutes left. And whomever I have marked in red and whomever I have marked absent, please do not change it. Okay? Even I will come to know if you change it. Meanwhile, I'll be displaying the attendance sheet of yours. Kindly check your attendance. Okay, it should be greater than 85 as per the norms of PTU. Okay, we will be sending the attendance for the university in the weekly basis. So it's very, very important. So that is the reason why I'm sharing that particular thing with you. Okay, just have a check and leave the class. If any questions are there regarding the attendance, if there are any changes required, you can talk.
Sir.
You can be in the meetings, or else you can leave. Okay.
ಸರ್
Yes.
ನೀವು ನನ್ನ ಅಟೆಂಡೆನ್ಸ್ ಹಾಕಿದ್ರಿ ಸರ್, ಪ್ರೆಸೆಂಟ್ ಅಂತ ಮೊದಲೇ ಅದೇ.
ಹೌದಾ? ತೊಂದ್ರೆ ಇರಲಿ, ಹಾಗೆ ಇರಲಿ. ಶೇರ್ ಮಾಡಬೇಕಲ್ಲ ನಾನೀಗ.
ಹಲೋ ಸರ್.
ಹೇಳು.
ಸರ್, ಮೊನ್ನೆದು ಬ್ಯಾಲೆನ್ಸ್ ಶೀಟ್ ಇದು ಸಾಲ್ವ್ ಮಾಡಿದ್ವಲ್ಲ, ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್.
ಹೌದು.
ಅದ್ರದ್ದು ರೆಕಾರ್ಡಿಂಗ್ ಉಂಟು ಸರ್, ಅದೇ ರೆಕಾರ್ಡಿಂಗ್ ಸೆಂಡ್ ಮಾಡ್ಬೋದಾ?
ರೆಕಾರ್ಡಿಂಗ್ ಉಂಟಲ್ಲ, ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಅಪ್ಲೋಡ್ ಮಾಡಿದ್ದೇನೆ. ಇವನ್ ನಿನ್ನ ಗೂಗಲ್ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಅದರ ಲಿಂಕ್ ಶೇರ್ ಮಾಡಿದ್ದೇನೆ.
ಹೌದು,
ನನ್ನ ಚಾನೆಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಗೆ ನೋಟಿಫಿಕೇಶನ್ ಬರುತ್ತೆ.
ಎಸ್ ಸರ್, ಓಕೆ
ಸರ್. ಚಾನೆಲ್ ಹೆಸರು
ನನ್ನ ಹೆಸರು ಕಣ ಮಧುಸೂನ್. ಇದು ಒಂದ್ಸರಿ ಯಾವ್ದೊಂದು ವಿಡಿಯೋ ಓಪನ್ ಮಾಡಿ, ನಿಮಗೆ ಅಲ್ಲಿ ಗೊತ್ತಾಗುತ್ತೆ.
ಸರ್, ನಂದು ಅಟೆಂಡೆನ್ಸ್ ಪರ್ಸೆಂಟೇಜ್ ಸರ್.
ಇದು 1 ನಿಮಿಷ ರೆಕಾರ್ಡಿಂಗ್ ಸ್ಟಾಪ್ ಮಾಡುವ.